Why do stars have different life cycles? Imagine looking up at the night sky and seeing stars of all shapes and sizes shining in different ways. Have you ever wondered why some stars burn bright for billions of years while others fade away much faster? The secret lies in their initial mass, which is the main factor shaping how they form, change, and eventually die. Stars begin their journey in huge clouds of gas and dust called nebulae. Gravity pulls this material together, causing it to clump and get hotter. When the core temperature reaches millions of degrees, nuclear fusion starts. This process turns hydrogen into helium and releases a lot of energy, making the star shine. This is the birth of a star. The amount of mass a star gathers during this process is what determines its entire life story. Low-mass stars, like our Sun, burn their hydrogen fuel slowly. They stay in a stable phase called the main sequence for billions of years. When they run out of hydrogen, their cores contract and heat up. This causes the outer layers to expand and cool, turning the star into a red giant. Later, these stars shed their outer layers, creating a glowing shell called a planetary nebula. The core left behind becomes a white dwarf, which is a dense, hot object about the size of Earth. Over time, this white dwarf cools and becomes a black dwarf, fading into darkness. Intermediate mass stars burn their fuel faster, so they have shorter lifespans. After the red giant phase, they become supergiants, which are much brighter and larger. When they run out of fuel, they explode in a supernova, which is one of the most powerful events in space. The explosion disperses elements into space, enriching the universe. The leftover core can turn into a neutron star, an incredibly dense object only about 6 miles across that spins rapidly and has strong magnetic fields. High-mass stars are the biggest and fastest burners. They become blue supergiants, which are hotter and more luminous than other stars. Their supernova explosions are even more energetic. Because of their large mass, their cores collapse beyond the neutron star stage, forming black holes. These are regions in space with gravity so strong that nothing, not even light, can escape. All these different endings happen because of how much mass a star has. The mass influences the internal pressures and temperatures that drive nuclear fusion. It also determines how long a star can resist gravity's pull before collapsing or exploding. Understanding why stars have different life cycles helps us see the variety of stars in the universe. It also shows how stars recycle elements back into space. These materials from new stars, planets, and even the building blocks of life. The life of a star is part of a bigger cycle that shapes the universe and our own world.